Welcome to logarithmic differentiation. So the idea here is some derivatives can be rather horrific to take. Oops. So some derivatives can be quite horrific to take, particularly if there are lots of product, quotient, and powers involved. And it turns out if we take logarithm on both sides, we can manipulate using logarithm rules to simplify the derivative process. So if we take the natural log ln of both sides, let me give myself some more room. If we take the natural log of both sides, we can use log rules to manipulate. So the derivative is actually easier to take. So for a quick review, let's go ahead and just look through the log rules that are at least going to be useful in logarithmic differentiation. So the log rules useful for logarithmic differentiation. First up is if we have a logarithm with a product inside. A product inside the logarithm corresponds to addition outside of the logarithm. So log base b of x times y is log base b of x plus log base b of y. If we have division inside the logarithm, log base b of x over y, this corresponds to subtraction outside of the logarithm. So this is log base b of x minus log base b of y. Remember, the logarithm essentially is talking about the exponents. So if we have a product of b to the x times b to the y, the exponents wind up adding. If we have division, b to the x over b to the y, the exponents wind up subtracting. And then the last one, if we have log base b of x to the n, this is the same as n times log base b of x. Again, that stems from the fact that if we do b to the x and then raise to the n, the repeated powers is multiplication in the exponent. So using these three rules, we can do quite a bit of manipulation. So let's go ahead and find the derivative of f of x equals x plus 3 to the 5th times 2x minus 7 to the 8th over 5x plus 3 to the 6th. So in this problem, we would have to do a product rule, a quotient rule, and multiple chain rules if we wanted to find this derivative. So what we can do instead is we can take the natural log of both sides I'm going to use y instead of f of x. So let's go ahead and say that this is y equals f of x equals. So we have y equals, and then we have x plus 3 to the 5th, 2x minus 7 to the 8th, all over 5x plus 3 to the 6th. Then we are taking the natural log of both sides. Then we can go ahead and separate across products and quotients. So this becomes the natural log of y is equal to the natural log of x plus 3 to the 5th plus the natural log of 2x minus 7 to the 8th minus the natural log of 5x plus 3 to the 6th. So again, that's using the fact that a product becomes addition and division becomes subtraction. At this point, we can also pull out the power. We can only work with the very last operation at once. So the product and the quotient and products would have been the last operations. Now the last operation would have been the power if we were to evaluate. So we can go ahead and pull those powers out. So we have the natural log of y is equal to 5 times the natural log of x plus 3 plus 8 times the natural log of 2x minus 7 minus 6 times the natural log of 5x plus 3. At this point, we can go ahead and differentiate implicitly. We've done no differentiation yet. We've just been manipulating the original equation. So now let's go ahead and differentiate implicitly. So we'll take the derivative of both sides with respect to x. So we have the derivative with respect to x of natural log of y is equal to the derivative with respect to x of 5 natural log x plus 3 plus 8 times the natural log of 2x minus 7 minus 6 times the natural log of 5x plus 3. If we do the differentiation on the left-hand side, chain rule, we differentiate first with respect to y. So natural log of y would go to 1 over y, multiply by the derivative of y with respect to x. So we have our 1 over y times dy dx equals, and then on the right-hand side, we'll have some chain rule. So we'll have 5 times the derivative of natural log is 1 over. So we'll have 1 over our x plus 3. And then we should multiply by the derivative of x plus 3. And we have plus 8 times, again, natural log is 1 over for its derivative. So 1 over 2x minus 7. Then we should multiply by the derivative of 2x minus 7. And then we are subtracting minus 6 times, we have 1 over 5x plus 3. And then we should multiply by the derivative of 5x plus 3. So we have 1 over y times dy dx is equal to, the derivative of x plus 3 is just 1. So we have 5 over x plus 3 plus, then we have the derivative of 2x minus 7 is 2. So we wind up with plus 16 over 2x minus 7. And then the derivative of 5x plus 3 is 5. So we wind up with minus 30 over 5x plus 3. And then at this point, we have dy dx equals, we multiply both sides by y. We have y times 5 over x plus 3 plus 16 over 2x minus 7 minus 30 over 5x plus 3. And then y was that whole, let's see, y was originally x plus 3 to the 5th times 2x minus 7 to the 8th all over 5x plus 3 to the 6th. So we can at this point plug back in. Y equals x plus 3 to the 5th times 2x minus 7 to the 8th all over 5x plus 3 to the 6th. And we have, therefore, that y prime or dy dx, originally our f prime of x, is equal to x plus 3 to the 5th times 2x minus 7 to the 8th all over 5x plus 3 to the 6th times 5 over x plus 3 plus 16 over 2x minus 7 minus 30 over 5x plus 3. We could at this point distribute, do a little simplifying, etc. But this is what we wind up getting as our derivative.